All right, so number 4 says find the area enclosed by the graphs of y equals square root of x and y equals x minus 2. So we're going to draw a picture of that. So square root of x, that'll give us 0, 0, 1, 1, and 4, 2. And then we've got x minus 2. So it's going to start at 0, negative 2, and have a slope of 1. So up 1 over 1. Oh, sorry, it was and the x-axis. I was going to say, isn't this the x-axis as well? And the x-axis. So this is the area that we're looking at. So the area problems do not jump right out and tell you if it's dx or dy. You kind of just have to look at it. This one is going to be a dy problem. We don't have a clear winner for upper graph minus lower graph. They intersect right here. It actually almost looks a little easier to tell if you look at it upside down. See how they cross right there? So you don't have one that's above the other all the time. But if you turn it sideways, the line is above the parabola all the time, like going this way. So this is going to be right graph minus left graph. So as soon as you realize it's going to be a dy problem, you have to go back and rearrange the equations. So this one, we're going to square both sides. And this one, we're going to add 2. And then when we set up our integral, we're going to use y values for the boundaries. So it will be from here to here. So 0 to 2. And right graph minus left graph. So the right graph's the line, that's the y plus 2. Minus the left graph, which is the y squared, dy. This is really washed out today. There we go. All right, so antiderivative, that's going to be 1/2 y squared plus 2y minus 1/3 y cubed from 0 to 2. And I told you you didn't have to simplify these down. So honestly, you could just plug in the 2 and leave it as is. A lot of you went a little bit further, so I'll go ahead and do that. 2 squared would be 4. Half of that is 2. 2 times 2 is 4, and then 2 cubed is 8, so minus 8/3. All right, and would you guys like to pick another one? I'll do up to 3 of them. That's what I did with my other classes. So if you want to pick another one, and you can type it to me privately if you're feeling shy. All right, number 7. All right, so find the volume of the solid whose base is bounded by the graphs of. All right, we've got y equals square root of x plus 1, and y equals x over 3, which is 1/3 x plus 1. So let's go ahead and graph that. And when we graph this, this is just the base of this 3-dimensional object. You have to envision, your cross sections popping up out of the paper at you. All right, so we are going to start with this graph at 0, 1. And then we'll have the points 1, 2, and then 4, 3, and 9, 4. All right, and then this graph, again, going to start at 0, 1. It has a slope of 1/3, so up 1 over 3. So you get this teeny little space in here. All right, now it says that the cross sections are rectangles and the height is 4 times the base. So whatever we get for the base, the height is going to be 4 times that. And it says perpendicular to the y-axis. So all your cross sections are going this way. So it's going to be right graph minus left graph. That's what the base of your rectangle matches up with, is right graph minus left graph. And so again, we're going to have to rearrange these equations. So for this one, we're going to subtract 1. And then to get rid of the square root, we're going to square that. And then this one, again, we're going to subtract 1. And to cancel out the 1/3, we're going to multiply through by a 3. So we're going to distribute a 3 to everything. So there's your two equations. Again, we want to do right minus left. So that's the line minus the curve. So the line is 3y minus 3. And then the curve is the y minus 1 squared. Now, the height of the rectangle is going to be 4 times that. I'm not going to write that all out again, but the height is 4 times what we got there. This again was right graph minus left graph. So setting this up, we're going to use our y values. So it's going to be from 1 to 4. So look at your y-axis for that. And then inside of here, you're going to put the area of your shape. So it's base times height. And so it's going to be 4 times all of this squared. The reason it's squared is, again, the height is 4 times that exact same statement. So you get this times 4 times this again. So it's easier to just write it as squared. And this one, you can type in the calculator. I know it says y, but I'm going to type x. It's just easier since you have a variable key. So integral 1 to 4, 4 times, and you could put the 4 out front of the integral if you wanted as well. All right, 3x minus 3 minus parenthesis x minus 1 squared, close parenthesis, squared dx. It's a lot to type. Typing it is a skill. You got to practice that as well. All right, 32.4. And you can just write 32.4. Some people put the zeros at the end. That's fine too. If the decimal stops and that's all that it is, then you're fine to just put that because that's the entire answer. It's not like you rounded it off or anything. That's just it. All right, and then I will do one more if you guys would like. All right, number 5. All right, so this is one where I think you guys made good choices about which ones you asked about. We did one that was an area, one that was a cross section, and then this one's a disk or wash one. Find the volume of the solid formed by rotating the region bounded by. All right, y equals 2x squared, y equals 0, and x equals 2. Let's go ahead and draw that. So 2x squared, we're going to have a point at 0, 0, 1, 2, and 2, 8. And I'm not drawing the other half of the parabola, which would be over here, because I'm going to end up erasing that anyway. We've got the vertical line at x equals 2, and then y equals 0 is just the x-axis. So I'm kind of only drawing the part that I need, because I would erase everything around that anyway. All right, it says we are going to revolve that around the line y equals -1. So that's right here. And I'm going to draw my ghost shape on the other side, so this mirror image shape. And so again, remember this is round, it's going to be like a funnel, like if you look at it this way. So we've got the hole through the middle. So this is going to be pi r squared minus r squared dx or dy. Well, it's like we took the x-axis and just scooched it down a little bit. So it's going to be dx, which is cool, so we don't have to rearrange any of these equations. X values for our boundaries, so it'll be 0 to 2. Outside radius, upper graph minus lower graph. So the upper graph is this 2x squared minus the lower graph, the axis you're revolving around is -1. So it would be minus -1, which is going to be +1. And then the inside radius, again, it's upper graph minus lower graph. The upper graph is the x-axis, so that's 0. So this would be 0 minus -1, which would just be 1. And again, what most people do is they'll just look at this and go, oh, from there to there is just 1 unit. So that's going to be 1. So multiplying this out is going to give you 4x to the 4th plus 4x squared plus 1. And then minus 1 squared is just 1. So conveniently, those are going to cancel. And then our antiderivative is 4/5 x to the 5th plus 4/3 x cubed from 0 to 2. And again, you can just plug in too. And some people went further with evaluating it, but honestly, you could just do this. And I had some people do this too. Either way is fine. I would do the way that's, the least amount of work. You just need to be careful with your parentheses if you do those.